Hi, welcome back to my channel. Today we are going to talk about horizontal pod autoscaling, how Kubernetes engine will give us that flexibility when there is a demand uh, required to load more pods, and that we call it as the scale out. And then when the demand fulfillment completed, it scales down automatically. So for that, we supposed to enable horizontal pod autoscaling mechanism, which is a autoscaler concept. So let us try to understand what is Kubernetes horizontal pod autoscaling. This is a process which is used to scale out and scale down pods automatically. Okay, this is the fundamental. We're supposed to follow certain basic declarative instructions which has to be provided. We don't increase the pod resources like CPU and memory. Say if I am defining a CPU limit and request limit as a resource, the same will be used to scale out the pods. That is the constraint. And as I said, when the load is high, we have to also increase our pods to fulfill the demand. Why do we need the HPA? So when there will be a high load usage of our application from web or internet requests, then our application also should able to elastic way to behave to fulfill the requests. Otherwise, we will get into different types of errors. For example, timed out error or connect error or something else which is not good as an application owner. So this also will give you an additional benefit that the total cost of ownership, because you are not keeping all 8 pods, suppose if you wanted, or you want 10 pods up and running. When there is a demand, yes, you scale. When there is no demand, scales down. So that's how you can also save some total cost of ownership of the applications. What are the tools and technologies used to test high load volumes? So we can use JMeter, WRK, web client, etc. In this exercise, I am using WebFlex, that is a web client. So to test this approach, HPA apply to different kind types: deployment, replica set, stateful set, replication controller. So this is how my physical architecture. I have a Windows operating system. I have a virtual box where it is running Linux guest operating system. Inside that, I am running a Minikube operating system. In that, I have hosted a pod, and that is exposing 8080 port. To access the port, I'm using outside of the Linux VM port forwarding technology. Okay, these are the servers up and running in my local for testing this scenario. And these are the prerequisites: Docker public registry, because I'm going to use my public registry for getting the images, and Kubernetes up and running. Here I'm using Minikube, and intended audience at least 6+ of Java developers so that they can understand better, and architects. So these are the reference links, and now we will jump into the hands-on session. Stay tuned, watch until last so that you can understand much better. I'm creating a client which is of a web, as I said, asynchronous web client, which is going to use 20 thread pools and 50k iterations. If you want to increase, yes, you can go ahead and change. And I'm putting the load and I'm making call as a asynchronous basis. Okay, so if you look here, I'm making use of it. I'm using a thread pool executor mechanism, and then I'm making call 50k iterations or 100k iterations, depends on the load which I wanted. In this particular case, I'm using 50k iterations and making call which is asynchronously being called and then getting the response and collected into the response list, and then I'm going to retrieve, and then I'm just printing. This is my load testing. Okay, so you can use this library, which is also available in the GitHub. So this is the agenda of the readme file. You need this and the additional environment. Spring reactive web client I'm using, and 20 threads in thread pool and 100k iterations. Screenshot how Kubernetes automatically elastic way it performs for us. So let us get into the Kubernetes. Understand. If you want to know more details, already I have created part 126 to more details about Kubernetes and different varieties. Please go ahead and understand. So here I am going to have a deployment and service, two types of configurations. One is for the pod deployment. You can see that this is a deployment kind, and this is the metadata, all the details. If you want to study all these things, please visit my previous part, Kubernetes engine. So this is how we can declaratively specify a deployment, and then I can specify a container, and the container can bind to no IP address, and then I am defining the resource constraints, limit constraint and request constraint. Maximum limit CPUs 500 milli CPUs, memory 200 MB, and the request can be served CPU up to 100 milli CPUs and memory 100, and this pod is going to use 8080 port to run the service. And we will see, to access this Kubernetes port outside pod port, I am having a node type, and which is referring to the pod metadata label, so that it will talk to this pod. And service port is 8080 and target port is 8080. The target port is matching with the container port. Now let's go ahead and deploy this into the Kubernetes. So I am using kubelet client namespace ns-realtime apply-f. So now I just created one of the deployment, get all. Now I can see that there will be a pod created, and this is the deployment. Deployment is using replica set by default. Now I can inspect. Okay, I supposed to use the namespace. I forgot to place the namespace, because sometimes we declare in a default namespace. Namespace is important to rectify. This is a simple Spring Boot application which is up and running. Now I need to host a service to get access. Now I can see this service also hosted. Now you can see that one pod which is of a Spring Boot, and this is the service to access it. Now I can go ahead and access using curl localhost 8080. Okay, so we are not within the Kubernetes engine, that's why this port is not allowing. So we wanted to access from the outside. For that we had to do the forward enablement. So that's what I'm going to do it now. So now this is enabled. I can access it from my web client. Okay, now you can see that the results has been printing whatever the REST service is exposing, which is of a pod, which is of a Docker image. Okay, now I wanted to enable my namespace with Autoscaler enabled. So I'm going to do that. So now I have deployed Autoscaler. Now let me go ahead and see. Now after I have launched, before I could see only one pod. Now my Autoscaler has been deployed. Now you see that there are two pods because the Autoscaler is saying that if you look at it, Kubernetes namespace Autoscale deployment type, this is the name of the deployment. Minimum 2 pods required, maximum 8 pods required when CPU reaches 60%. So that's the reason now switch it to from one pod to other pod. This is the newly created pod. This was the pod first created. Okay. Now we are going to main program to put some load. As I said, I'm going to put 50k iterations and 20 threads, which is going to submit asynchronously. Now I'm going to, now the load has been changed to 28%. Now still it is 28% load. Now it has reached to 224%, and now you can see that the pod started creating container creating. These are already running. Okay, so because of the Autoscaler which we enable, that will start as per the demand for requests, right? So it is creating these pods. Now again, if I do the refresh, you can see all 8 pods. Now minimum pods 2, maximum pods 8, replicas also 8, because to fulfill the request 50k records which is sent by my driver, that is the load testing application which I am running in the workbench, so that the load has been increased, and then automatically the Autoscaler started evaluating the current CPU percentage, and then it is still in progress. Now it has been changed to 111%. That means maybe it served some load and still it has to serve another 111%. Still it is serving. We have not received any response from the request. of this loader test. Okay, because it has to send 50K records to the server. Now still it is increased, so still serving all the pods. Still 118%. So we need to wait for some time so that the request load test will be completed. We can issue get HPA. We can see that this is now it has changed the target percentage 112 and minimum pods, maximum pods, replica pods. Age is 4 minutes. The deployment which we enabled the autoscaler. Again we can see this still 112%. We can see in case more descriptive, if you want to know about how this is being performing. So initially only one pod was there, that has been resized to new 2 size, then 4 when we applied more load, and then 4 has been increased to 8. This is how internally Kubernetes mechanism automatically scales. It will not directly scale all 8 pods once. It goes incremental fashion. Even the scaling down, it happens incremental fashion. Like this, you can try to see, understand how this is being performed. Still, you can see that 1, 2, 3, 4, 5, 6, 7, 8. 8 pods are serving and load is 105%. Still 105%. Still 105%. Still same load, there is no change. Now it has changed to 48%. We can count 1, 2, 3, 4, 5, 6, 7, 8. Still serving 8 pods. Still 48%. We have not received any statements printed. That means no results arrived. Still 48. We'll try to see, is there any change? No, the same. Still 48%, which is serving. Likewise, Kubernetes does auto scaling, and when it is a demand request, scales out. When demand fulfillment completes, scales down the pods automatically. This is where the cost of ownership will be reduced based on the use case requirements. Now it has reduced 48 to 45%. Depends on all how your actual Kubernetes cluster is working to fulfill these demands. Here everything I am running in one of my local machines, may be little slower. Still 45%. Now it has changed to 43 and minimum pods, maximum pods, replica still 8. That means all 8 pods working to serve the request. Still 43. Still 43. Still 43. Still 43%. Now it has changed to 3%. Let us see, is there any results? Okay. Now we see that we got the results for our 50K load, and this automatically fell to 3% utilization. Now we will try to see how this horizontal pod autoscaler changing. So it has not changed yet. Still we can see all 8 pods. 1, 2, 3, 4, 5, 6, 7, 8. So eventually it is going to kill the newly created pods. Now it changed to 2%, like the beginning. Still we can see that 8 pods. 3, 6, 8. Still the pods running. Maybe it is not serving, but it is ready to scale down automatically. Now you can see that 3, 3, 6, 7. Now we can issue the command. That means the new size changed from 8 to 7. That means scaling down started. Still we can see 7 pods. Now you can see that 3, 3, 6. That means 1 pod scaled down. It new size 7 to 6. Likewise, scales out, scales down. If you want to test it, yes, of course you can test it. The code is available in the GitHub. Please like it, share it, subscribe it, comment it. I come up with new video. Until then, stay tuned.